you. So we will start with Rajesh's talk exactly at 11. But before that, we wanted to spend a couple of minutes to brief you about the iMobile ECM chapter and what our charter is and how we would like to help the ecosystem here uh, mature to the type of systems research that we have been very passionate doing. So let me introduce myself. I am Prashant Mishra. I am the current chair for the ACM iMobile chapter. The ACM iMobile chapter is the India chapter of SIGMOBILE. So it's a very new chapter established in India. It was chartered officially on the 18th of March 2019, which means that we are just over an year since operation. So we have listed down a couple of points for you to make a note of. So that's the website for the iMobile chapter, and the you can reach us at the email ID sigmobile.india@gmail.com, and there are a couple of social media handles for you to follow and get updates on what we do. All our communication will be coming through the new logo that we have just designed. You can see over there, it's called the iMobile chapter of ASM SIGMOBILE. Now, moving on to the next slide, just to give you what the charter of iMobile chapter is. Since we are India-centric society for SIGMOBILE, we adhere to the charter of SIGMOBILE Global. And the SIGMOBILE Global's charter is to bring together researchers and practitioners who perform research in the theory and practice of areas relating to mobility of systems, users, data, and computing. And we hope that we will be able to expand and help in the evolution of portable computers and wireless networks, and so that we can support the convergence of mobility, computing, information organization. The long-term impact that we want to achieve is to improve access, services, management, and applications for mobile computing and communication. So that's the broad charter of SIGMOBILE since its inception, probably 2.5 decades ago. Now, the India-centric charter here is that we would definitely like to adhere to the global charter, but we want to develop a greater passion for system research in the country. And we believe this is an area that the country can do really well. And we are here to create that ecosystem and excite researchers who would want to take a dive into doing system research. Okay. Moving on to the next slide. So this is a team for 2020. I have introduced myself. Amit is a vice chair for the chapter. He is a principal engineer in Cisco. Then we have Sandeep Chakravarti as a treasurer. He is a faculty in IIT Kharagpur. Then we have Karthik Mullidharan, who is also organizing this webinar series. He is the secretary for the chapter, and he is a scientist with TCS Research Innovation. Then we have Vinayak Naik, who is a professor in BITS Goa. In fact, he's the head of Department of Computer Science over there, and he drives and leads the membership development activities of the chapter. Then we have Rohit Verma, who is the web chair for the chapter. Rohit recently graduated from his doctoral program from IIT Kharagpur and has joined as a postdoc at the University of Cambridge. We have an excellent mentoring team. We are mentored by three stalwarts in the field of SIGMOBILE, Dr. Venkat Padnavan, Professor Suman Banerjee, and Dr. Rajiv Shauri. Moving on to the next slide. As part of our chapter activities, we have one flagship event that we run every year. It is called the ACM Workshop on Autonomous and Intelligent Mobile Systems. So we started last year. We had the inaugural series last year. This workshop of the iMobile chapter is co-located with CompsNet. This year again we are running it. This is the second series and it will be held on Jan 8th, 2021 in Bangalore. So we have provided you the link, URL link to this workshop. So we request you to take a look at the workshop details and the scope of call for papers. In addition to that, we would also like to call out folks to join the iMobile chapter here in India. If you log into our web page and you go to the membership development area in a tab called Get Involved, there's a link wherein you can fill in your details and we will add you to the iMobile membership list. Now, to become member, there is no additional criteria for iMobile. Either you can be an ASEAN member or a SIGMOBILE member, and that makes you directly eligible to become a iMobile member here in India. So as I said, we are a very new community, and we are trying to build the or accelerate the this culture of doing system research in the country. We believe there is a great potential for creating impact through this mode, and all our chapter activities have been directed and will be directed in the future to support researchers both in industry and academia who are very passionate to take this forward. With that, let me just end and let me hand over to Karthik, who will drive the rest of the session. Thank you.
Good morning, everyone. Thank you for joining. Hope you're all keeping safe. Can you hear me? Prashant, just give it.
Yes,
Okay.
Karthik, we can hear you. Yeah.
So writing a paper is really an art. It might seem simple, but it really isn't. So when we decided to start a webinar series for this chapter, it was kind of apt to kick off the series with this topic, and who better than one of the stalwarts of the SIGMOBILE mafia, as I'd like to call it. So Rajesh is an associate professor at the School of Information Systems at Singapore Management University and an active member of the SIGMOBILE community. Some of you might have met him during the CommSnet sprints that happens every year in January in Bangalore. And today he'll be sharing some tips on writing a good systems paper, as well as some insider information on what reviewers are looking for. So thank you, Rajesh, for being part of our inaugural series. Before I hand it over to you, there are some ground rules. Everyone stays on mute, please, and video also turned off since we are recording the session. During the session, please use the chat to ask any questions and make sure that it is directed to everyone. Everyone can read the questions that are posted. And it kind of reduces any duplicate questions, because I'm sure some of you might have the same set of questions, right? At the end of the session, depending on the time, we can open the floor to audio questions. Rajesh loves interactive sessions, but given that there are almost, I think, 100 people that have joined, it might be a little tricky, but we'll try and figure it out, again, depending on the time. This is our first webinar series, and this is the kind of protocol we thought we will follow. If you don't like it or you have any suggestions, please do mention it in our feedback, and I will post that once this session is over. Okay, so Rajesh, I'll be stopping this screen sharing. You can take over.
Got it. Thanks. Can you all see my screen? Yes? No?
It's visible, Rajesh.
Okay, cool. Well, good morning, folks in India. Good afternoon, folks in Singapore and rest of Asia in this part. Thank you, Karthik, Prashant, Vinayak, Rohit, and the rest for inviting me to give this talk. Sandeep as well. I'm delighted to give this talk. So a bit of background for where I'm coming from. This is my perspective, right? It is not the official perspective. There is no official perspective of how to get papers accepted. It's a bit of luck sometimes, to be honest. So this is what I think you need to do, right? And it comes from having been on a lot of PCs, having written a lot of papers, and having served as a chair for Mobisys, CommSnets, and a couple of other things as well. Okay, so with that, as Karthik mentioned, I love things to be interactive. I have the chat window open on another screen, so please chat in there. Like I can see comments from Ilangoban, Vaishali, Anik, I've already replied to him. So please post whatever you feel like you need to say about the talk, questions you have, you want me to elaborate about something, anything you want at all, right? Just post it there, I will see it, and if I can do it, I will, okay? So let's go on. So first things first, what is the general flow of a systems paper, right? When we say systems papers, we mean a lot of things in general, right? So to give a bit of ground setting, what I'm going to do is going to be applicable to Mobisys, Mobicom, and Imwood. And it's going to be for what I call systems papers, where you actually build something and test it. it will not be that, it will apply somewhat to theory papers and less to other kinds of papers, but this is more for things where you actually build stuff. Okay, and the general flow of a paper, I believe you can hopefully see the mouse, is there's a title, right? Then an abstract, and then these sections in some order, right? Introduction, background. I will cover all of these in more detail. Systems, evaluation. Now, what makes a systems paper different from theory and other fields is these two sections in particular, right? These three sections, the evaluation methodology, the in-lab small-scale evaluation, and the larger scale evaluation. Now, this section 6 is actually what differentiates the top venues from other venues. If you do not have section 6 in particular, it's actually really hard to get a MOBICOM or MOBISIS paper, and I'll explain more in detail. Okay, then discussion, related work, and a conclusion. And the most important part of a paper, surprisingly, or maybe not surprisingly to some of you, is actually the introduction. If you mess up the introduction, your paper is almost guaranteed to be rejected, right? And a good introduction can overcome a lot of limitations in the other sections, up to a point, of course, right? But the introduction is the most important part of the paper, which is why a lot of my talk will actually be spent on how to write a good intro. Okay, let's go on now. So first things first, I talked about intro, right? But before intro comes two things, the title and the abstract. Now, from experience, I've realized that when you first start writing a paper, people tend to pick really, really long titles. You know, they put everything in the title, and it's really long and incredibly boring. And that's not good for your paper because it does not make your paper stand out, right? The title is the first impression reviewers get. In fact, for many conferences, for example, ComsNets, the title is the only thing you actually get to see if you actually bid on papers, like IMBOOT, for example. When reviewers bid on IMBOOT papers, they basically get a list of about 600 papers that are submitted every cycle. And based on the title, and if they choose to the abstract, they get to specify the interest for the paper. Now, most reviewers may not actually look at the abstract because imagine looking at the abstract for 600 papers. So most likely they're only going to use the title. So for the title, please make sure it is short, descriptive, and something that will actually map to your paper. Please don't have a misleading title or a title that makes no sense, because if that happens, you'll only get reviewers who really don't care. And that doesn't help your paper either. You want to get the right reviewers. So you need to put a title that is short enough that people can read it quickly and descriptive enough that people actually understand what's in your paper, right? Because for many conferences, this is what people use when they bid for papers. This is true for MOBISIS, MOBICOM, and IMBOOT in particular, okay? The next thing people read after they actually get your paper, or if they decide to actually read it while bidding, is your abstract. So this is the second most important thing at bidding time and when people actually start reading your paper. It is not the most important thing for accepting your paper. That, as I said, is the intro. But it's the second most important thing when people bid for your paper, because some reviewers will actually take the trouble to read the abstract. They'll go beyond the title and look at the abstract. And that is why a good abstract will make reviewers want to keep reading your paper. In this case, read your intro. So your abstract basically should cover four main things. What is the reason for your paper? As in, why are you actually writing it, right? And it can't be because you need to write a paper. Yes, we all understand that it's the number one reason why you wrote the paper, because you need to write a paper. But when you're writing the paper, that should not be the reason. It should be something, you want to save the whales, solve world hunger, something. It has to be a good enough reason that actually makes sense. After that, please specify your main innovations. What is the innovative contribution of this paper? A lot of papers fail to put this clearly, and therefore people look at it and go, oh, this is just a solution with no real problem or no real innovation. So you need to cover what is the main innovative contribution you have. Then your main results, and please pick the best results and the ones that are actually correct. And in general, those are the three things that your abstract has. What is the reason, the main innovations, and the main results. And it should be longer than a conclusion, but in some ways, the abstract is still lacking in real detail. It's just a teaser, right? After that, once people have got your paper and they've actually decided to review it, then they will actually get the paper itself and they'll start reading the intro. Now, remember, when reviewers bid for your papers, they do not actually get your paper. They only get to see the title, in some cases, the abstract. Only after they get assigned your paper, then your paper actually goes to them and they can see the rest of the paper. So that is why the intro and the abstract are just to get people interested. What they will actually read when they finally get your paper is the intro. And you need a good intro, okay? Because the intro is the first substantive thing that people read. Your abstract only is a teasers. Your intro actually covers real details, as you'll see later. And this is important. Many reviewers won't tell you this, but it's commonly known that reviewers decide whether to accept or reject your paper based on the intro. As in they assign it a probability, right? It's usually binary. Okay, after I read an intro for a paper, I will put the paper in 2 buckets. Possibly accept, reject. That's it. Yeah, and very rarely has a paper for me personally gone from my reject pile to accept after reading the rest of the paper. As in after I've read the intro and decided that this paper is not going to make the bar, very rarely do I change my mind because the rest of the paper was much better than the intro. So a bad intro will really kill your paper, but a good intro just keeps the process going. It doesn't get your paper accepted, it just keeps the process going, right? But it gets reviewers excited. Okay, the most common thing that happens to papers that fall in the possibly accept pile is the rest of the paper does not match what the intro promised, and therefore they get rejected, right? The intro says, okay, we'll test on 2,000 people, and the rest of the paper tests on 6. That is guaranteed to get your paper rejected, by the way, right? So the takeaway for this is a bad intro will kill a paper. A good intro just continues the process, but it's necessary to keep the reviewer excited. Yeah. Now, what are the parts of an intro? Because like I said, an intro is very important. So what are the most important things that you want to put into an intro? Yeah. First part, there are basically 5 parts in intro. The first part is the high-level motivation. This is the starting part of your intro, what you would call your opening paragraph. And this is 1 to 3 sentences only, right? And in this case, please try not to be please try to realize that the reviewers are all experts, right? So don't start off with things like the internet has changed the world. You know, everyone knows this. The internet is 20 years old now. Or, you know, IoT is the next big thing. It's not the next big thing. It's already come and gone in many ways, right? So please, the high-level motivation, get to the point as quickly as possible and don't put statements there that will make reviewers roll their eyes, right? Things that are obviously true. You want to get to the point quickly because remember, reviewers read a lot of papers. So any paper that takes longer than it needs to get to the point already is going to make a reviewer annoyed. Then after you spend 1 to 3 sentences with a high-level motivation, so why are you addressing this problem? Then you want to go into the details. The next paragraph, what are you doing precisely, right? This is very important because the more vague you leave things, the less likely a reviewer is going to like your paper. Remember, reviewers are experts. They actually know what's going on in this field quite well. So you want to make it clear to them what you are doing, right? Don't leave them guessing. Because by one of the big secrets of a reviewing panel is reviewers have way too many papers to review. As such, they are very happy to reject papers if the papers are not good enough. So you want to give them a reason to accept your paper, right? Now, why is this important, useful, groundbreaking? This is also very important. You know, it can't just be because this is a cool thing to do. Yeah, sure it is. Everything is cool, but why is it important, right? So if you can't convince yourself why it's important, it's very hard to convince someone else, right? And usually the best way is with a compelling use case, a short use case, no? Like this, if we use this, we will improve the efficiency of a data center by 20%. That's a big deal. Something like that, right? About 1 paragraph, get to the point, and the best bits fast. Then the next few paragraphs, 1 to 3 paragraphs, is why the problem is hard. A lot of reviewers, a lot of intros forget to do this completely. They just assume that everybody understands why the problem is hard. Please don't assume this, right? Reviewers come in all shapes and sizes from all kinds of backgrounds. So please don't assume that it's obvious why the problem is hard, because it may not be obvious to a reviewer. So you got to state it very clearly and very simply why this is a hard problem. Why is it research and not engineering? And this is very tricky for people to get right. Many problems are important. Not all problems are research. Many of the solutions required are actually engineering, as in you take known solutions and just apply to a different domain. That's not a research paper, right? A research paper usually involves creating something new. from scratch. Even if you have to take 3 different things and add a new bit to it, that new bit is what's important, right? So you got to say why the problem is hard. And you may need to cover related work here. Okay. After that, the next part is where you excite the reviewer by then telling them what is your insight to solve this problem. Because remember, you've told them what the high-level problem is. You've said why it's really hard or why it's important, and then you also said why it's really hard. So now the reviewer is hooked. So then you got to tell them how you actually managed to solve it. What is your killer insight, right? Or technique or secret to solve the problem. And this also requires about 1 to 3 paragraphs. And it's got to be interesting here, right? And also grounded in related work. This is important because especially if you're in a field where there's a lot of related work, you got to make it very clear that you're aware of it upfront and that you know about it and you've extended beyond related work. If you don't put that here, reviewers go in with that doubt already, and they're not less inclined to like your solution when they finally find out. Okay, so if you're in a very if you're in a very hot area, for example, you're doing, say, DNN offloading, which is super hot these days, make it clear what your new insight is that goes beyond what other people have done. Okay, and finally, summarize your key and most impressive results. So those are like the 5 parts of the intro, right? To recap: high-level motivation, detailed description, why the problem is hard, what is your insight, and then summary of key and most important results. If you have all of that, the reviewer is now hooked. And then to help them understand clearly, have a last section, which is your key contributions. This is very important because it helps give a guide to the reviewer saying, this is why my paper is important. There's these 3 to 4 things. You know, you should not have too many contributions because it's usually not possible in a paper. The max I've seen is 6, and that is way too many already. Usually it's about 3, maybe 4. Right? What are the 3 or 4 things that your paper provides that is really new? That it's something that if the paper is accepted, everyone else will be reading your paper to understand those 2 to 4 things, right? And here's where you can't lie, because this is what reviewers will check. And if your paper doesn't match what you claim the contributions are, your paper will get rejected. Most papers fail here. They promise a lot and they don't deliver on it, right? So their contributions either are not clearly stated, they make the reviewer try and figure it out themselves, or what they state is actually not right for what the rest of the paper shows. Okay. So let me, are there any questions about the intro? Because this is all I'm going to cover about the intro in per se. And now I'm going to go into the rest of the paper. The intro, as I said, is very important, but there are like 6 parts of the intro that you need to put in, right? And every good intro has these parts. Now, what about the rest of the paper, right? Because I've only covered the intro. And now, how long is a good intro? Usually the intro should not be longer than 1.5 pages, right? Your intro should not be more than 10–15% of the paper, right? So 1.5 pages is for a Mobius paper, which is 12 pages. In intro, we don't need previous work. You only put previous work where it's necessary. For example, if the problem is why the problem is hard, you may need to cover related work here if it's a very well-known area. Similarly, what is your insight technique? If it's a very well-known area, you might also need to put related work here briefly, just to make sure that the reviewer is not double guessing you immediately, right? But you have no place to put related work in the intro. There's a whole section called related work for that, where you go into depth. The intro is to explain your solution, right? So you just need to ground your solution in relation to the key related work, right? And make it clear why your paper is important, not someone else's paper. What are some incorrect writing styles? For example, mentioning the paper structure. See, I don't really, a lot of papers have that, try and put an index at the end of the intro. You know, in section 1 we cover, in section 2 we cover this, in section 4 we talk about intro. My sense for that is don't waste space. The paper is short enough that people can find your sections very quickly. I usually don't have enough space to waste on putting an index in the intro, so I never put indexes in my intro anymore. If you have the space and you want to put it in, go put it in. It's wasted words because nobody actually uses that, as far as I know. So don't bother, right? Because no reviewer actually cares about your index. So I would not bother putting an index in, right? How do you measure the novelty of a problem solution in the intro? How to write intro a wide spectrum? No, That's an interesting question. If you can't measure the novelty of your problem, you should not be writing the paper yet. That's my honest answer here, because you are the one writing the paper. You should be able to say, why is my solution novel compared to the related work? If you haven't figured this out, it's hard to write the paper, right? So you should be able to say, I mean, you assume that the experts who are reviewing your paper are from the area, right? Unless you're sending a paper to a completely different area, right? Say you're sending a DNN paper to a theory conference, then yeah, then it's up to you, right? But if you're sending a mobile systems paper to Mobisys, assume you're going to get an expert reviewer. So you, as long as you ground it in related work and show how you're different, people will get it, right? Because you will get at least one expert reviewer, which I'll cover later. In the intro, can we mention any further promising ideas? You can try, but it generally won't convince anyone. Your intro should say what the paper covers, not what you might do later in the next paper, right? That's discussion, right? Your intro should cover why the reviewer should take your paper. Now, again, this is for a paper you're submitting for review. After it gets accepted, then it's different, right? Because now your paper is written for archival purposes, for a general audience. So this is, all I'm talking here is for paper that you're submitting for review. So don't waste time talking about what might be the next paper. Don't put in an index. After your paper is accepted, yeah, then you might want to tweak the intro a bit to add in bits for a more general audience, sure. But this is for the review version, okay? So for the rest of the paper, should we mention tools? Put in your most important results. That is number 5. Summary of key and most impressive results, whatever they are, right? And abstract, yeah. In the abstract, again, like I mentioned earlier, in the abstract, you want to put in your main results. Just 1 or 2 lines on your main results. Okay, so let me move on. The rest of the paper, okay? Usually in systems papers, the second section is background or motivation, because it's usually important to make sure that people understand why your problem is important. And you can do it using a scenario, or if your solution is in an area that is not that well known to the audience or the reviewers, you may have to give a bit of background, like explain some theoretical foundation or explain the area, etc. Right? If you're in a really, really important area, or really, really hot area like DNN offloading, etc., you may be able to skip this completely because the motivation and background might be crystal clear. But generally, most people, at least for the papers I write, I found it useful to put in a background or motivation section to explain with a scenario, etc., that is longer than what I can put in the intro for why this problem is important, or to explain some key concepts that the reviewers may not understand. Yeah. Okay. And then the next section is the system. And I call it system in general. It can be called many, many things. You could put a name, you can call it many things. Here's where you describe what you built, right? What is your solution, right? What have you actually put in? This could be an algorithm. This could be a whole system. This could be parts of many systems. This could be one large chapter with subsection. It could be multiple chapter sections, right? It's useful to have a short name to describe your system. Otherwise, in your paper, you'll be talking system, system, system all over the place. So you might want to think of a cool short name. The shorter, the better, because if it's too long, then you run out of space as well. Now, this is important. Another thing that people always mistake, again, like I said, the difference between research and engineering. This system should only describe the research contributions, right? Things which are actually engineering, like how much time you spend coding, your code length, your XML scripts, all of that should not go here. They're just a waste of space. They go into your thesis, they go into your tech report, they go into maybe your journal, longer journal version. They don't go into the conference submission because nobody's going to read it, right? No reviewer cares about how nice your XML scripts look like. They just ignore it, right? So don't waste space, right? If you want, you can have 1 or 2 lines just saying how you built the system. It was built. I spent 2 years on my thesis. The paper, I can tell you personally, I spent 2 years building the system for my thesis. The paper describes it only as 2 lines on the implementation. It was implemented in C and over, 100,000 lines of C, and it took about 2 years. That's it. That's all it boiled down to, because that's all that matters for a paper, right? It's hard to accept, but that's the truth. Engineering efforts should not be described unless there is a research component to it. Okay. Yeah. Now comes how you evaluate it. Now notice the system itself is only section 3. You note that after this, there's 3 sections on evaluation, and this is what separates a systems papers from most other papers. Mobis's papers are usually 12 pages plus unlimited references, and of those 6, most papers have 6 pages of evaluation. Now think about that. At least 50% of the paper is spent on evaluation, which tells you where the bar is for systems papers. Systems papers, the bar at the top conferences are that you have to prove it works, right? You describe what you built, but that's usually, the intro is usually 1 to 1.5 pages. The background motivation, half a page. The system, 2 to 3 pages. And then the rest is on evaluation, right? That's basically the length that we're talking about, because that is the bar that the systems conferences have. And if you look at all of them, OSDI, SOSP, NSDI, even SIGCOM systems papers, Mobis's, Mobicom, you'll see it's all like that. About 50% or more of the paper is spent on evaluation, right? And that is why evaluation comes in 3 sections. The first section, which people sometimes forget, but if you forget this, it's very hard for your paper to be accepted because the reviewers won't understand how you did the evaluation. So you need a section talking about the methodology. How did you do your evaluation? What were your design criteria? What were your evaluation criteria? And how did you actually decide what parts were important to evaluate, right? This is extremely important when you have a mix of small scale and large scale evaluations. You got to say what was the goal for each of them, right? And what was the setup? You know, how many users? How do you recruit people? If you have a user study, you got to give full details of the user study procedure, make it clear that all IRBs, which is permission to work with human subjects, was obtained. You know, all those things, right? Is it preferred to have related work? I'll come to related work soon. Okay, sorry. Okay, press the wrong button. Okay, after the evaluation methodology comes what I would call small scale experiments. Now you could have many words for this. You can call it sensitivity analysis. You can call it in-lab experiments, small scales. This is where you show that each individual part of your solution works, right? So for example, you have a large system, right? You show that component 1 works, you show component 2 works, you show component 3 works, and you show it working under many different cases, right? You show it under the, you know, for example, if you're building something to detect metals, you show that it can work with many different metals. If you're doing something with Wi-Fi indoor localization, you show how it works with different types of RSSI signals. Okay, this is where you show that the sensitivity of your system, where it works, where it breaks. Okay, this is important to show where it breaks if the breakage is not fatal to your solution. Let me say this clearly. If the breakage is fatal to your solution, never show it, right? Hope that the reviewers don't point it out, but they probably will. If the breakage is not crucial to the system, it happens under some weird corner case, please go ahead and show it. It shows that you actually understand your system. Reviewers appreciate that, right? Where you show where the system breaks, as long as it's not fatal to the usage. Show the corner cases, show the sensitivity. This is important. Make sure you show the sensitivity in terms of precision, recall, AUC, standard deviation, you know, all the metrics you need that show how your system behaves under variability. This is very important. A lot of papers that get rejected do not show the variability. They just show accuracy. Now, accuracy can be fudged in so many ways, and all reviewers know this. So don't just show the best case. Reviewers will catch it. But again, don't just show only bad cases. No one will accept a paper that only has bad cases, sadly, right? Unfortunately, no matter what reviewers say about they love negative papers, nobody will accept a negative paper at a top venue. Sadly, right? I fought for this, but it's not going to happen anytime soon. So make sure that your solution works. Okay, and this is small scale. Now comes the other part that separates Mobis's, Mobicom, and IMWOOD and SIGCOM, etc., from other venues. This is the section, larger scale real world experiments. This is key for top venues. It is extremely rare for simulation only papers to be accepted these days at the top venues, right? And top venues in SIGMOBILE are IMWOOD, Mobis's, Mobicom. I'm not going to cover MobiHot because I have no experience with that venue at all, right? I reviewed for it 10 years ago, but I've not been involved, so I can't say anything about MobiHot. But Mobis's, Mobicom, IMWOOD, and Hot Mobile, right? Even the top workshop. If you only, Hot Mobile is okay with simulation, etc. results because that's a workshop. But the 3 top conferences, you only have simulation results for a systems paper, it's very likely you get rejected because it means that your solution doesn't work in real world. Right? You have to have some kind of evaluation of the real prototype in some kind of pseudo-realistic environment. Doesn't have to be a large-scale real world experiment, but it has to be something that at least shows it can work in the real world, right? The only exception are domains where real world testing is not possible. Say you're doing something with 6G wireless or something with like, that's going to the depths of the ocean, right? In those cases, maybe a simulation is possible. And I have seen papers getting accepted in those very specific domains where simulation results are accepted. But for anything else, simulation only unacceptable. You can use simulation for small scale, but you need something that shows how this thing will work in the real world. Okay, and you need sufficient users, durations, and samples. And one sub point, DNNs in particular, everybody loves DNNs. Unfortunately, they need a lot of data. So please don't submit a DNN paper where you've tested it with 20 users, data from 20 users. That's not enough, unless each of those 20 users is generating 1 million data points, right? If you only have 100 data points and you're using a DNN, yeah, it's very hard for you to get accepted in a top venue because you're clearly overfitting. So while DNNs are cool, please make sure you know when to use them. Okay, otherwise stick to things like decision trees, etc. Okay, after the evaluation comes the discussion, right? The discussion is where you cover the larger implications of your work, and this is usually half a page to 1 page, depending on what your area is and how much what you think the implications of your work are, right? You cover the larger implications of your work, state the obvious and some non-obvious limitations. This is where you demonstrate your perspective about your work and also where you state the limitations. It is better for you to point it out than for the reviewers to point it out, right? So if you can point out the limitations in a way that makes it clear that you understand and it's not fatal to your paper, the reviewers will be willing to let it slide. Yeah, so this is also an area for you to talk about the limitations of your paper in a way that is professional, to convince reviewers that, hey, I understand this. Yes, it may not work under this situation, but it's okay, and this is why, right? And as long as you are somewhat okay, reviewers are willing to let it slide. Because reviewers understand there's no perfect paper. Generally, the more senior a reviewer is, the less worried they are about having a perfect paper. Yeah, the more junior a reviewer is, unfortunately, they tend to get hung up on things like that. But at the top venues, you will get a mix of junior and senior reviewers. And the senior reviewers will make sure papers don't get rejected because people are worried about one corner case. They know that corner cases will always happen. It's how the authors address it that matters. Okay. Now comes related work. Usually related work comes at the end of the paper, unless you're in a very, very hot area. And if you're in a super hot area or in an area that has been researched to death and nobody actually cares about it anymore, related work needs to come up front, because you need to prove to the reviewers immediately that you know what's already being done and why you still have something to contribute. Okay, but usually you're in an area that is not neither of those things, so you put the related work at the end. And here you want to cite the most relevant work, right? Whatever you feel is the most important thing. And this is key. It always surprises me how much related work does not do this. In fact, I just reviewed a paper last week that had the same problem, and for that reason, they're not getting accepted either. They cite all the important related work, but they don't actually make it clear why their solution improves on any of those work, right? It's not enough to just say, I know what's out there. You also have to say why yours is different and actually is important, different in an important way. Saying it's different itself is not good enough. You need to say why it's different and important, right? And for conferences, please make sure you cite the work of likely reviewers. Reviewers tend to be very antsy if you do not cite what they believe is their most important work. So please check the PC before submitting. At least do a cursory glance. Sometimes you can't, I mean, for things like IMWood where they have 100 AEs, do the best you can. But for Mobicis or Mobicom, at least for the senior PC, try to make sure you cite the work of the most likely reviewers. Because even if they don't review it, they might hear it being discussed and they will still ask, did he cite this paper? Did they cite this paper? Did she cite this paper? Right? So you want them to not get too annoyed, right? Now, not citing 1 or 2 papers is not fatal, by the way. It just makes people more happy about your work. It's fatal if it's only fatal if that 1 or 2 papers are the most important papers in the field. In that case, then your paper will almost never get accepted. Okay. And like I said, related work, end of paper, exception of area is very well known or already researched to death. Then you put it after the intro and explain why your solution still matters, right? For example, if you're writing any paper today on RSSI-based Wi-Fi indoor localization, your related work needs to be upfront because nobody cares about this anymore. There's like 1 million papers out there and they all claim to have improved it and it's still not a solved problem, right? So please, if you're working in this area, I know some of you are, put your related work upfront, right? If you're doing anything like DNN offloading, put it upfront because that is now an industry problem, which means industry is already going much, much further than academia can. So this is also a thing. If you're in an area where industry is actually putting billions of dollars, like data center networking, I know data center power management, DNN offloading, etc., put your related work upfront. Right? Can we elaborate on the evaluation subsections? Yeah, you can. Yeah, this is just the main sections, right? You can have as many subsections as you want. In fact, you should have good subsections when needed. Comparative analysis. So Vaishnavi asked, comparative analysis important. My research is new in research field, how to compare. If you are doing truly novel research, good for you. You are 1 in 1 million. It is very rare to do something that no one else has done before. Somebody has done it. You just need to find it and compare. It might be that very few people have done it, which means it's great for you. That's a low-hanging fruit. If you're one of the first in an area, it's actually great because it means that the bar for evaluation is much lower. You just need to show that you are better than whatever is a plausible comparison, whatever the baseline is. And if no one else has done it, you get to pick a plausible baseline and explain it. If a lot of people have done it, the baseline is the last most important research paper. And that's a much harder baseline because you've got to go and evaluate that particular solution. Okay, so that's why it's always useful to find areas which are not heavily researched yet, but which are still important, right? Because that's important. If nobody cares about it, then it may not be an area you want to look at either. Where should we mention our benchmarks in any particular? How to find all possible related work? Brute force search, yeah. DBLP, Google Scholar, ACMDL, IEEE, Explore. Those are your friends. Or read the most recent papers in this field published at the top venues because they would have done a good job as well on related work. Where should we mention our benchmarks and any tips on benchmarking methodology? Benchmarks, etc., go in experiment methodology, what your benchmarks are and why they matter. And the results of your benchmarks go in the different sections. Okay, so if you're using a benchmark, that has to go into the experiment methodology and why your benchmark actually matters, right? Please pick a benchmark that people care about. Finally, conclusion. Now, conclusion is actually really important because once people get your paper, a lot of reviewers actually read this after your abstract because it's short, right? A lot of reviewers, myself included, like to get a quick understanding of the paper. So they'll read your abstract, then they'll read your conclusion. In my case, I read the conclusion first because it's shorter than the abstract, right? Conclusion is usually only a few lines. And in the conclusions, you want to just make the reviewer eager to read your paper. So have the main goal, your key innovation and your key results. And this is even shorter than the abstract, right? So conclusion is like a super teaser, but make sure that it teases the reviewer to go read your abstract and then read your intro. Okay? And many reviewers actually read this first because it's short. So think of this as like a teaser. Okay. Now I finished the parts of a paper. I'm looking at all the questions. I think I've answered everything. If I haven't answered any of the questions in the chat, please post what I haven't answered.
So Rajesh, I'm keeping tab. I think post that I can mention some of the questions that were asked that you haven't covered.
Okay, I think I've covered most of it, but yeah. Okay. Important question. Notice I didn't have future work because future work, every reviewer knows future work is just rubbish. Nobody actually does the future work. So it doesn't actually help or hurt a paper. So if you have it, great. If you don't have it, it doesn't help or hurt your paper during the review process. It's good when you finally have an accepted paper because you want to put it in future work to help, students, to help someone else who might read your paper later with ideas. But during the review process, future work is a no-op. It doesn't help or hurt a paper. You can put 1 or 2 lines in the conclusion to say, look, and you can use the future work as a nice way of saying, look, we haven't done this. Say, okay, we haven't done this, we put it in future work, or you can put it in discussion, right? What are the things that you have not done? Future work is a form of a non-obvious limitation, by the way. You can call it a future work. Said, we haven't done this, we will address it in the future. Okay? Now, common rejection reasons, right? This is coming from what I see from PC meetings. And this, again, is only my impression. Okay? It may not be true for other people. This one always makes me sigh. Always spell check your paper and fix your references. You'll be amazed how many papers are submitted with spelling mistakes, including papers which are spelling mistakes in their title. That is just inexcusable. We know grammar is hard, right? English is not a first language for most people, but there's a 1,000,001 spell checkers out there. There is no excuse for not using it. And if you have a spelling mistake in your title, well, nobody's going to accept your paper. Right? If you have a spelling mistake in the first line of your abstract, again, nobody is going to like your paper. So please, please, please check. And this is spelling, right? Grammar is hard. It's sometimes when you do spell check, you might get the wrong word instead of the word you need. And that's a grammar mistake. Those people are less hung up on, but obvious spelling mistakes, please make sure you fix it, right? Reference errors, please make sure you fix it. And this is particularly important with people using the online tools like Overleaf, etc. Okay, because everyone just clicks compile and they don't actually read the log to see all the red errors in there, which are usually reference errors. Please make sure you fix all your reference errors before you submit a paper. Reviewers who read your paper and find question marks inside instead of figure, question mark, etc., they are less likely to accept your paper because you couldn't be bothered to check it yourself, right? Sure, everybody is up against a deadline, but just you have to understand that reviewers have too many papers. So please make sure your paper is spell checked and all your references are fixed. Yeah. Now, the best thing you can do is get a good English writer, not a good speaker, a good writer. Good speakers may not be able to write and vice versa. Get the best English writer you can find and ask them to check your intro. Okay, because that's the most important section and the hardest to write. Just ask them to read your intro and help you fix it, right? Remember, people have a lot of work on their hands, so they don't usually have time. So use whatever time you can get from people to read your intro once you've written it, right? Just ask them to read your intro, which is 1.5 pages. You might be able to convince them to do that rather than read your full 12-page paper. Right? After that, fix your system algorithm description, because if people don't understand what you built, they won't accept it. Then the lowest priority is results, because results are usually quite easy to write. Yeah, they're just numbers, they're just this is higher than that, etc. So even if your grammar is not great there, you can generally get the idea. Lowest priority is related work. This is usually horribly written because it's always the last thing written, but as long as it gets the points across, it's fine. Right? Make sure your intro is as well written as you can, then fix the system algorithm. If people don't understand what you built, it's very hard for your paper to get accepted. Okay. Next, clear and legible figures. Again, there's a page limit. Yes, we understand this, but that's no reason to have figures that are in 4-point font, because if I need to magnify the figure 20x just to see it on my monitor, I'm not going to accept your paper. Right? Having 20 lines on a figure, it does not help because nobody can read it. 3D graphs are ridiculously hard to read. I know they look great. They're great for public demos to convince the public that you have something, but they're terrible to convey any kind of information. Yeah, especially when they're colored in 6 different colors. So please don't put 3D graphs. Please don't put graphs with multiple lines. You know, things like that. And if you have graphs, make sure make sure they're large and they're labeled properly, right? Make sure they are labels. Please don't have graphs with no axis labels, because it's really annoying to have to read the text to figure out what the graph is. And the more you annoy the reviewer, the less likely they will like your paper. Okay? Then you have to explain the figures and algorithm systems in the text clearly. What do I mean by this? Let me give you a few things that papers like to say because they think it's really cool, but it doesn't actually help them. Okay? The first thing, lots of authors like to say, as you can see, right? I hate these 4 words, by the way. All my students know this very well. If you write as you can see in any paper you write for me, I'm going to remove it immediately. As you can see, to me, maps to I see nothing. And most reviewers understand this as well. As you can see, we do well. It just means we see nothing, right? This applies for talks. This applies for papers as well. Please don't use as you can see, because it kind of tells the reviewer, look, I'm better than you, right? I'm showing you something which you cannot see, and you cannot see anything. So explain what it is that you need them to see. Explain it clearly. Look, this line is here, this line goes there, this means that, this means that. Next thing, without loss of generality, when it's not clear why this applies. Reviewers are smart. They understand that this means that you have scalability issues. If you go, oh, look, we have shown n equals 2. Now, without loss of generality, this means that n equals 1000 also works. Yeah, we don't believe that at all, if it's not clear. And the last one is, in the interest of space, x is omitted. Yeah, most reviewers know what this means. You haven't done it. Okay, so if it's not obvious, if it is that important, please don't say in the interest of space you omitted it. If it was that important, please do it. If it's not important, don't mention it. Right? If it was important enough for you to mention and then you mentioned that it was omitted, yeah. Now, of course, if this is a proof and it's very clear that you omitted it because you get most of the proof already, sure. But when it's used for system papers, people usually go, and in the interest of space, we don't describe the hashing algorithm because it's obvious it works. Yeah, it may not be that obvious, unless it really is. Okay. The next common set of reasons, the experiment setup must be crystal clear. What you use, what parameters. If you don't understand your results, your paper is rejected, right? And many papers actually do not explain their results at all. They just present magic results, right? They describe the system. They say, look, and we evaluated it, and this is a magic graph. How did you get the magic graph? It's not clear how you got the magic graph. What did you do to produce those results? If it's not clear to reviewers what you did to get your results, we are not accepting the paper. If you did a simulator, please explain how you validated it. Reviewers do not think random simulators are correct. So just because you say, I wrote a simulator and then we tested it and it's correct. Yeah, garbage in equals garbage out. If your simulator is broken, yeah. If you use a well-known simulator like OpSim or NS3, yeah, we might be more inclined to believe it. But if it's your own simulator, how did you validate it? Yeah, that's important for the top venues. Okay, and for systems experiments, description of how data is flowing through your system, what was connected to what input outputs you use, what granularity of measurements, data you use, explain the hardware, software setup clearly. All of these things need to be there. Because if we don't understand how you got your results, we cannot accept your paper, right? So it all comes down to clarity. Make sure you explain how your results are generated, right? And then explain your results. Okay, these are all the reasons why papers get rejected. And they won't tell you this. In the reviews, it will come out as, and your results weren't good enough. That's what the review will say. When it's actually deeper than that, it's we didn't understand your results because you didn't make it clear how you collected it. Okay. If you have user studies, yeah, you need to give lots of detailed user studies. If you're doing user studies, please make sure you go read up about how to write user study papers because they are very specific in what details you need to put in. Right? Just saying we tested with 10 people is not good enough these days. You need to say how the 10 people were recruited, what were the instructions, what did they do, what are the demographics, and what was the bias. Because it's very easy to produce results that are highly biased, right? And people don't realize this. There are so many biases in place when you're dealing with humans that you need to be aware of how you manage to correct for those. Okay, and finally, the last thing is you need to provide error bars and explain outliers. It's amazing how many papers produce results where there's an obvious outlier that's never explained. And reviewers will always gravitate to the outliers. They'll want to know why is this particular point so far up again above the rest of the points? What happened here? And if the authors either don't say anything about it, we immediately believe that something went wrong with the experiments, right? It was not as controlled as they believed it because there's an obvious outlier. They don't mention anything about it. How generalizable your results? You need to show the t-test, AUC, precision, recall, all the metrics that show how generalizable your results are where applicable. This is important. Okay. Now, another common rejection reasons, and this is related to what some of the questions in the chat is asking about. You assume domain knowledge. Yeah, this is very important when you're in an area where you are where there's only 2 or 3 people on the PC who actually understand what you're doing. For example, you're submitting a paper on mobices, you're writing a paper on, wave solutions. There's only going to be 3 or 4 people on the entire PC that understand waves, which means the rest can read the paper, but they're not experts. So you got to make sure that they understand what you're talking about. So if you're using lingo that's specific to a domain, make sure you explain what the lingo is, right? This is why you have a background motivation section. Reviewers may not be experts. In fact, it's better you don't have experts. The worst thing you can do to any paper is assign all experts to review it, because experts are brutal, right? If you have an indoor localization paper and you get 5 reviewers and all the experts, that paper is never getting accepted, right? You need a couple of non-experts who will actually think out of the box and say, this is useful, right? But then the non-experts, they need to understand the context and background. They come from different countries, they have different experiences, etc. So you need to set a common understanding. This is particularly important if you're addressing problems specific to certain countries, right? If you're addressing a problem that is well known to India, for example, you may not get an Indian reviewer or somebody who understands the Indian context. So you got to explain what is specific about the Indian context. For example, you can write a paper about solving the Indian traffic problem. Most reviewers from America have never understood what the Indian traffic problem is because they've never been to Bangalore or Delhi or any other cities. So you need to explain what the problem in traffic in India is and why it cannot be solved by what they believe would solve the problem in the Western world, right? So you need to set the context, you need to set the background. Otherwise, they're just going to reject the paper because they don't understand. Okay, so this is the background motivation. Yeah. So why papers get rejected at PC meetings? So I see a couple of questions, I'll cover them at the end, right? At the PC meeting, now the way it works for papers at conferences, now I'm only covering conferences, I'm not covering journals here. Journals are a whole different ballgame. Yeah, the journal process is very different. I'm only covering conferences and conference-like process. IMBOOT is used as a conference-like process, even though it's a journal. So it falls in here as well, okay? Why papers get rejected? Now, the way it works at conferences is that your paper goes through maybe 1 or 2 rounds. It will get a first set of reviews. If it passes the first set, it will then get a second set of reviews. And then if it's above a certain bar, it gets discussed, right? And during the discussion, which is usually all the PC members together, this is MOBISIS, MOBICOM. This is why papers will get rejected even once they reach the PC meeting. Firstly, there's no champion. For a paper to get accepted, somebody should be saying, I want this paper in the program. Yeah. And the way it works is a strong champion can overcome as many weak rejects as they are on the review panel, right? And many weak accepts are much lower than one strong reject. If you have a champion either asking for your paper to be accepted or your paper to be rejected, that works for or against your paper, right? And experts, of course, trump reviewers without domain expertise. So the best thing that can happen to your paper is you have an expert reviewer saying, I want this paper accepted. It's very unlikely a paper gets rejected. Conversely, the worst thing that happens is if an expert looks at it and says, this is broken. Nobody will accept your paper then, even if the rest of the reviewers think it's good, because they do not want the paper to be fundamentally flawed. Okay, so you need to appeal to somebody. This is why it's important when you submit to the top conferences, if you look at the PC and figure out who is likely to read your paper, and write it in a way that they will be more inclined to like it. So you cite their papers, you look at what they've done previously and make sure you compare against things that they care about. It's a bit of work, but it helps a lot. Okay? Because the paper must appeal to someone who's at the PC meeting. For journals like IMBOOT, etc., it's all done online, but even there it needs to appeal to someone. Either the 1 AE or 2 AE or some reviewer needs to say, I'm going to stand up for this paper. Then the paper gets accepted, even though there's no physical PC meeting. The second reason it gets rejected is because of lack of key related work, where key is this paper is so important we can't believe that they did not cite it, because that shows that the authors don't know what they're doing, right? And what this is changes in every domain. Now, sometimes it can be really unfair because it could be a paper that just recently came out, right? In which case the PC tries to be as fair as possible, but sometimes they just have no choice, right? You know, it just got accepted the last round of MOBICOM, which means you need to keep up to date with what just got accepted. As soon as you know about it, make sure you cite it if it's important, right? Because nobody wants to accept papers that are not state-of-the-art anymore, okay? And finally, results are not comprehensive enough. This is a very common reason to reject papers in the top systems conferences. You only show it in perfect conditions via simulations, or there's no sensitivity test or convincing deployment test. Now, what is the bar here? It depends on the area. Yeah, it's hard to say because if you're in Wi-Fi indoor localization, the bar is really high these days. If you're in something else, say emotion sensing for mood swings, it might be lower. It depends on your particular area. Okay, but you need to show that your solution works in less than perfect conditions. And finally, the most common reason is that your paper, the rest of your paper doesn't match what was promised in the intro. Your intro, you promise a couple of things, but the rest of your paper doesn't have it. And this means that your paper will almost always get rejected. Okay? You should not exaggerate the intro, but also don't underplay. Another common reason is you underplay, so people don't actually pay attention to your paper. They just initially go, this doesn't matter. Okay, so you need to be clear, you need to be correct. So I've reached the last slide for this part, right? So the main takeaways is, have a good descriptive title, have an excellent introduction, test your solution comprehensively, and provide all the key error and sensitivity analysis, right? And this is, if you do all of this, your paper has a much better shot than most other papers at being accepted. Now, of course, what you actually did matters whether it gets accepted or not. But if you don't have these things, it's quite likely that your paper will get rejected. Okay, so what this talk mostly is about is how to make sure your paper doesn't get immediately rejected. How to get it accepted? Again, you need to solve an important problem in a specific area and convince someone on the PC that this is important. What that is changes based on the domain. So I can't really help you with that unless you want to talk about specific research. Then I can help you figure out what might convince reviewers, right? But if you don't have these things, it's very likely your paper will get rejected immediately. Okay, so let's look at some of the questions. Karthik, do you want to point out anything that I should address in particular, or can I just go through them?
I think you can go through them. Just wanted to point out if in case someone had asked a question way up in the chat and it wasn't answered by Rajesh, if you post it again, I'm sure you'll discover it.
Sure. So I've covered important future work. Is literature comparison table a must thing? No, please don't waste time unless you're in a please don't waste the space unless, again, you're in a super hot area like Wi-Fi indoor localization. Right? If you're in a super hot area, then yeah, please make sure you compare as much as you can. It is quite confusing quite confusing how to verify if the system works in real world. Yeah, this is part of skill. And again, the question of lying is interesting because we always assume that papers are honest, right? If we ever get a sense that the authors are lying, the paper is immediately rejected. So all reviewers assume the authors are telling the truth. So please don't lie, because once you start lying and the word goes out that you are not telling the truth in your papers, it's actually a huge problem for you professionally, right? I don't understand this question. Sir, do you think there's any restriction for accepting review papers? I'm not sure what the question is. Possibly getting slides. Yeah, sure. Let me work with the SIGMOBILE India chapter and see what we can do here. Cover letters does not play any role in a conference because you don't submit a cover letter. For a journal, you only submit a cover letter for, at least for input, for major revisions or for resubmissions, in which case, yes, if you're doing a resubmission of a rejected paper for input, please make sure your cover letter makes it crystal clear what you have fixed compared to your previous version. Because if you don't put that in, reviewers are going to reject it again. Yeah. If for conferences, sometimes you get to specify something to tell the PC. And here, if your paper has been rejected previously, again, it really helps to say what you have improved, right? Because remember, there might be someone on the PC that reviewed the paper previously, so they'll know it got rejected. So it's better to be upfront and say, look, it got rejected previously. These are the reasons. We have fixed all of them. Make it clear you have improved the paper. It stands a much better shot then, because people will be more impressed and be more willing. Everybody understands papers sometimes get rejected multiple times. It's not a big stigma anymore. Even top researchers get their papers rejected multiple times these days. Yeah. How to differentiate background related work and the related work section. I meant background motivation, right? Background and motivation is things that the reviewers need to know to understand why your work is important, or some common language to understand your work. Related work is what has been done previously and why your work is more improves on all of that, right? So you can combine all of that, but they are fundamentally two different things. Pragma is asking, in case of real world, what's the average acceptable number? It again depends on what you're trying to do. For a mobile application, if you're claiming a mobile application in the App Store, there's papers these days which have thousands of users on Mobisys, right? So the bar is ridiculous sometimes. So again, you have to look at prior work in that area and see what is the new bar. If you are actually deploying a paper on app on the App Store, there's papers from China that claim to have thousands of users. Now, whether or not they do, it's unclear, but they have been accepted. Are there any specific items which should strictly go in appendices? Conferences don't have appendices. Even journals sometimes, IMWOOD doesn't want appendices. If you can't put in the main paper, please don't put in an appendix. Sometimes people put full proofs, but that's usually not needed for systems paper. Yeah, so I'd have no big insights on appendices. Table form, yeah. If I continue my work in the second paper, can I cite my first paper? Yes, but make sure you don't give yourself away because most conferences are double blind. You're not supposed to make it clear who you are. So you cite it in third-party form, saying this work improves upon the earlier work of et cetera, and please don't make it clear as yourself. If you do have to make it clear as yourself, then make sure you anonymize all the citations and say this work. And then in your citation, say you cannot say who it is. Does the reviewer see the count of the references being included? Yes and no. For usually if you need to have at least some number of references. If your references are usually below, say 15, it's usually not enough. But if all of them are URLs, that's not enough either. If your references are above 30, that's a bit excessive for a conference. Journals are different, but just make sure you have enough references. If you're in a particularly old area like Wi-Fi indoor localization, you might need 50 references. I kid you not. That is why the top conferences give you unlimited references these days. So please don't constrain yourself. Anything which you think is important, please cite it. Yeah, please don't have too few references. Better have too many than to have too few. If you have, yeah, proper flowcharts and workflow diagrams. I usually don't use flowcharts and workflow unless I really need to when describing a system because they take up too much space. If your system is really complicated, then yeah, you can have a workflow or a system diagram, but just have one and make sure it's clear enough. I don't really have any big insights here other than make sure it's legible. Please don't make it so small that nobody understands or can see it. Okay. What can or can't be changed when preparing a camera ready? You can change almost anything, but you shouldn't change anything substantive because your paper got accepted for what is in this paper. So you can't change the system. You can't change what you actually did. You should not change your major results unless asked by the reviewers. But you can add, additional bits as long as you satisfy the page limit because you will still have a page limit. Yeah, please make sure you go check the grammar. Okay, I think I covered all the questions. Are there any other questions that I did?
Rajesh, there was this question on any restrictions on accepting review papers. So I believe the person is asking if survey/review papers accept in conferences, these top conferences.
Surveys.
Survey or review of a certain field in terms of, so I think what it means that rather than having a technical contribution, can't we just submit review papers that surveys a field to a great detail?
So for the conferences, Mobisys, Mobicom, no, you cannot submit a survey paper. That's not considered a research paper. For IMWOOD, I believe they do accept survey papers, but I can tell you right now, writing a survey paper is really, really hard. Because to write a good survey paper, you need to really survey the field and you need to provide insights into where the field is going. Right? A lot of people have submitted survey papers and they usually submit bad survey papers. So if you want to write a survey paper, most likely you have to find a journal or a venue that supports it. Most conferences do not accept survey papers because they are not new research. Okay, so that's and my suggestion would be survey papers are really hard to write. Yeah, so we think it's easy, but writing a good survey paper is actually really hard. And not many are accepted because of that. Right? If you look at, there's even an IEEE journal for surveys, right? I forget what it's called. Is it IEEE survey? Something. Was that the question? Was there something else I can answer about survey papers? Mobicom now has a track talking about deployed systems. So if they even have an experience track because it used to be really hard to write experience papers in Mobicom. because the reviewers used to be really, really picky and wanted only new innovative contributions. And experience papers generally don't have a new innovative component because they're talking about what you have deployed and what you have learned from that. But now there's a track in Mobicom for those kind of papers. And Mobisys generally is much more supportive of experience papers, but even there, you got to write it in a specific way, right? Which you can see if you go look at past papers like the work by Gaetano about his system in his mobile application system in the Caribbean, etc.
Rajesh, one more question.
Yeah.
So we see a lot of this vision, the CFPs consisting of submitting vision papers as well. So what would you say is the ingredient for a good vision paper?
To which conferences? Mobisys, Mobicom don't ask for vision papers though.
So I don't recall the conference name, but okay, probably a year or 2 years ago in IA Census or someplace, we did see a special track for submitting vision papers.
Yeah, those are usually special tracks because vision papers generally are also very hard to write because a vision paper has to be a vision that other reviewers or a significant number of reviewers will actually be able to build on and create whole new areas of research. For example, I'll give an example, right? One of the test of time papers for SIGMOBILE is actually a vision paper written by my advisor, Satya, on the challenges of mobile and pervasive computing. He wrote it in 2001. That's a vision paper in many ways, right? And that's a really hard paper to write. Or for example, the Cloudlet paper, you could say was also a vision paper, which I think many of you have read, right? That's a short paper, I think 6 to 7 pages. But vision papers are really hard to write because you got to write something that could basically spawn a whole new area. If it's in a conference, writing a vision paper for a workshop is much easier because the bar is much lower. And in fact, many workshops will love to accept vision papers because vision papers are more provocative, right? There's a lot of things to talk about because your vision may be right, your vision may be wrong, but either way, the audience can discuss it.
I think the Cloudlet paper was in Hotmobile.
Yeah, and that was a vision paper. Yep. So vision papers usually show up in workshops. They don't show up in conferences unless in special tracks. But conferences tend to be for complete work, whereas workshops are meant for work that is incomplete or work that's more provocative.
Everyone, we are kind of reached the end. Is there any more questions that you would like to ask? Please post them now.
Yeah, please type. Do applying existing techniques on a new constructed data set considered novel? No, of course that's novel. That's what everyone does. Very few papers are what I would call truly innovative, as in everything is new. Almost everyone is building on past work and improving it in some way. So what you're mentioning is actually what all papers do. They take either an existing technique and apply in a new domain and show how it works in a new domain, or they take a new technique and apply to an old domain, an old data set, right, and show how that works. It's one of the two. Very rarely do they take a new technique and apply to new data. That's very rare. What's your comment on reproducibility in mobile systems community? It's right now terrible. We do not spend any effort on it whatsoever. In fact, it's horrible. We have no way to reproduce anything. And I believe this will be fixed moving forward. It's one of the things, I'm in an information systems school, which means we are the only tech school here. All the other schools around are social science business, and they are appalled at how poor computer science is in relation to reproducibility. In all the other fields like accountancy, business, etc., you need to be able to reproduce everything. So they provide data sets, they provide algorithms, they provide code or analysis code to make sure other people can reproduce. We don't do any of that, but it's getting better. Some of the communities are getting better on this, like machine learning, some of the systems communities, but we'll get there. Is the review process totally fair for a new set of authors? The PC members know each other. So yes and no to a point, right? Most of the top venues are double blind, and if you look at the program, you will see quite a lot of papers coming from what I would call new places. Places from institutions that are not your standard places, but it is still not fair because unless you got trained, for example, with a talk like this, you will write your paper in a way that will get it immediately rejected from the top venues. The top venues are fair in that who wrote the paper usually plays no part in whether they accept it or not. at least from what I've seen as the chair and from the PC meeting. If anything, if you are a well-known author and you wrote your paper in a bad way, you're getting rejected faster than a poor author. Yeah, PCs, at least the Mobisys PC, loves to take papers from unknown places. The problem is that if you do not write your paper in a way that they actually can appreciate, it's immediately rejected. And understanding how to write that paper takes experience. So that's where it's unfair, right? That experience is part of the learning process that most people don't get unless they come from places that actually have provided this experience for them. And that's the unfair part, which is why we do talk like this. Is it crucial to add in references to your code and results on GitHub? Yes and no. Saying that you will release your code and release your data after the paper gets accepted sometimes helps, but these days it doesn't because too many authors do it and too few actually follow up with it. So we know that many people just put it in to improve their chances, but they don't actually do it. Unfortunately, that's the state of the world, right? If you actually have released your data and released your code and you actually put it in your paper, people might look at it. So yeah, if you say you're going to do it, it doesn't help. If you say if you actually have done it and you actually put a link, yeah, it might help. For many of my papers, I actually put in anonymous link to a video showing how my paper, how my systems actually work in the real world. And I give a double-blind link to a anonymous YouTube video. So reviewers who care can actually look at the system actually working. That helps a lot in some cases. It's like them being able to see a demo of it. So you could do that. That's a nice trick that I've used over the years. Yeah, but make sure that your links are all anonymous.
I think it's a good time to stop. Rajesh has actually graciously mentioned his email ID. So if you want to flood it, please go ahead and ask him questions.
I rarely reply to my email anyway, so you can ping me on Telegram, which will get a reply much faster. Yeah.
Okay, this was thank you, Rajesh. It was fantastic. Actually, I was transported back to the classroom. A couple of you guys have a lot of you guys have asked whether we will be sharing the presentation. I mentioned in the beginning that this session is also being recorded. We will work with Rajesh and get it permission, and if it's fine, we will share the video as well as the presentation, and I will share the links for it. And yeah, I will also be sharing feedback link. Please do let us know if there were any suggestions on how we should conduct future webinars. And I will also, yeah, we've got a couple of sessions lined up, and we'll keep all of those guys who are attended today. You want to add anything else, Prashant?
No, I think we had a wonderful session. Thanks to Rajesh for actually taking out this time and talking to the audience, iMobile ASIM India chapter audience here. As Karthi was saying, it really took me back to my grad school days because I think these are some of the basics our advisors used to be very thorough about. And even after so many years of paper writing, I think I never heard somebody actually narrating it that clearly and that precisely. So really, thanks Rajesh for taking out time and talking to us in such a detailed manner.
Not a problem. Glad to speak. Thank you.
Okay, thank you everyone, and stay safe.
Thank you, folks. Bye-bye. Have a great
Thanks, Rajesh. Thanks,
great
everyone.
weekend.
Bye-bye.